Welcome back to the Bitcoin Layer. I'm Nick Bhatia. Today, I have the pleasure of welcoming Giovanni Santostasi. He is a PhD in astrophysics and has been researching the Bitcoin power law. Giovanni, it's very nice to have you on the show. We met in Las Vegas briefly. It was a pleasure. I had to have you on the show. We've had your colleague, Dr. Stephen Perrineau, on the Bitcoin Layer before. We've learned about the power law, but today I want to get your perspective. We'll get a fresh power law lecture from you. We'll understand why Dr. Perrineau contacted me in the first place, which was that describing Bitcoin's price action over its lifetime as parabolic is inaccurate from a mathematical standpoint. It follows more of a power law. So I'll hand it over to you. Can you explain to people where we see power laws in nature and the discovery of power laws themselves?
Yeah, so in physics, we are very, very familiar with power laws because, and Stephen makes a point of this all the time. They are everywhere in nature. They are very ubiquitous. I will not say all the laws of physics are power laws, but a majority of them are a large majority. Some of them, the most familiar ones, that people probably are aware, are things like gravity, how gravity works, right? It's the force between two planets, the planet and the sun, for example. It's inversely proportional to the square of the distance. So whenever you have a quantity that is proportional to the power. So let's say y proportional to x to some power. That means, like in the case of the gravity, will be the one divided the distance square, right? Or mathematically the distance to the minus two. The power will be minus two because we are dividing, so minus, and then the square two. So in that case, it's a power law. It's a power law between the force and the distance between the two objects. But they are everywhere. Like, for example, um, the distance of a planet versus the time it takes a planet to go around the sun, that proportion is um, the distance equal the time to 2/3. So that power can be anything. It can be any number, bigger than one, less than one. Bigger than one, less than one. In fact, it changes a little bit what the power law means. It depends if it is a number above one or below one. A famous one that also, so it's not in the physical world, of planets, particles, etc. It's what is called the Kleber's law, that relates the metabolism of an animal, so how much energy an animal consumes, that you can measure, in calories or watts, versus the size of the animal, and that relationship it goes in this way: the metabolism is proportional to the size of an animal to the three quarter. So the three quarter is very important. We can talk later. I have some slides to show you how the law works, but it tells us something deep about the mechanism behind this process. So the relevance of finding power laws is not that you just have now some kind of relationship. That is good, right? Because you can uh, tell, you can predict. Like, for example, if we didn't know the elephant, right? We didn't discover the elephant yet. We could predict that an animal with that particular size, if it was, will consume such and such energy, right? So you can make a prediction. These tools are predictive. So it's nice to have a tool like that that allows you to understand better, things that you don't know. But the importance and the depth of this understanding comes in the mechanism, because this is the beauty of physics, and this is why I want to use physics to understand Bitcoin. We make all the time a point in our show. We have this, me and Steven have this show on Wednesdays at 8 something Pacific time, In fact, today we have the next show. The reason to use physics is physics really focuses on why, right? Why something is happening? What are the mechanisms behind it? So discovering a power law is actually the starting point. It's not the end point. It means there is some kind of organization. It means there is some kind of order. There is some kind of mechanism that is creating such a power law. The power law is just the physical evidence, the empirical evidence that something is going on with the system. And so the relevance with Bitcoin is that once I discover not just one, but actually six different power law, in fact, there are even more in the behavior of Bitcoin, then the question is, okay, what makes Bitcoin behave in this way? What is the underlying mechanism? That is something that I try to emphasize all the time. This is why you see my slide here. I call this understanding of Bitcoin a theory, the Bitcoin power law theory. It's not just a curve. Like some people try to call it the power curve, right? And that actually de-emphasize the fact that it is a law. And we can discuss a little bit about what we mean for law in physics. But the emphasis in the law is that it's a process. There is some kind of powerful mechanism that determine this relationship between these two quantities. And this is why, I continuously insist that it's not just a curve, it's not just some model, it's something much deeper. It's a framework to understand Bitcoin.
Is Bitcoin's next parabolic move starting already? I want you guys to go check out this report at unchained.com/TBL about liquidity. Now, it uses a slightly different methodology than we do at TBL, but I really think that you guys would benefit from checking out this report and understanding Bitcoin's relationship with liquidity. Unchained and TechDev break it down in a new report. Visit unchained.com/TBL to get that report right now. Blockstream Jade Plus is the easiest, most secure way to protect your Bitcoin. Perfect for beginners and pros alike. With a sleek design, simple setup, step-by-step instructions, you'll be securing your Bitcoin in just minutes. Seamlessly pair with the Blockstream Green app on mobile or desktop for smooth onboarding. And if you want more security, Jade Plus supports multi-sig wallets with apps like Blockstream Green, Electrum, Sparrow, and Spectre. Protect your Bitcoin, sleep better, and stack harder. Use code TBL for 10% off. Go to store.blockstream.com. Use code TBL for 10% off. The Financial Freedom Report is a free weekly newsletter from the Human Rights Foundation. It tracks how authoritarian regimes are weaponizing money to control their populations and suppress dissent. It also spotlights how technologies like Bitcoin are helping everyday people reclaim their financial independence and freedom. A one-of-a-kind newsletter connecting the dots between financial repression, geopolitics, and emerging technology. Smart macro analysts don't just watch the Fed, they watch the world. Go to financialfreedomreport.org to sign up for the free newsletter. We love frameworks. That is the basis of research, really. It's having a theory to discover a framework. That's how we approach global macroeconomics at the Bitcoin layer. I love that you say that you're using physics to understand Bitcoin and that there is physical evidence of a power law within Bitcoin. I'm fascinated by this idea that there are 6 different power laws at least within Bitcoin. Can you explain some of these 6 briefly?
Yeah, and I have slides, but
You can jump all
I
around
made
as you
I
need
made
to.
this presentation many times so people can follow. So I like actually to have more of a conversation with you. So maybe we can focus on this particular
Take your time
questions. Yeah,
to reach each slide. Yep.
yeah. So the 6 power laws are these, right? And there is a history of how I discovered them, etc. Over time. The first ones identified. In fact, the history behind that is, I joined this Bitcoin world quite early. In fact, I downloaded the wallet all the way in 2010, and then unfortunately didn't do very much because it looked a little bit complicated. At that time to mine, with your wallet, you could do that. It was that early. You could actually use your desktop to do that. But people don't realize that is one of the things I want to communicate how difficult it was several years ago to actually be a Bitcoiner because there was no much information. There were no shows like yours, etc. So it was very difficult to even understand the general concept. But then later on in 2012, I read an article from a futurist point of view. I was part of this newsletter that told us about future development technologies like AI and so on. And in the article there was a graph, and this was 2012, so it didn't have a lot of data, but they claimed that was that Bitcoin was exponential, and Bitcoin is not exponential. I can show you why in a moment. Um, but I was very familiar with this idea that technologies evolve like exponentials. This is something, for example, Ray Kurzweil, he wrote this book, The Singularity is Near. He has dozens and dozens of these charts showing that anything that has to do with the digital world eventually becomes exponential. But Bitcoin is not like that. It's different. So I started to study, trying to understand Bitcoin even before I bought Bitcoin. Um, and in fact, actually studying it is what allowed me to jump in and, you know, um, invest in this in this worldview is actually right because Bitcoin is not just an investment; it changes your way of thinking about the world. But and while I was in this process, I heard this TED talk by this physicist. His name is Jeffrey West. In fact, I suggest everybody to watch the lectures. I can send you a link, so maybe you can put it in the comment of this interview, and also read his book. His book is called Scale, because actually power laws are also called scaling laws. So this concept of scales that I'm going to describe, it's very fundamental to understand what power law are about. And he wrote an entire book about this phenomena of scaling all around us. Um, and when I heard that lecture, he was talking about how, I was very familiar with power laws because we found everywhere in science. So physicists are trained to work with them, developing mathematical tools to find them. But my missing piece was I didn't know that other physicists, were starting to use their techniques and tools to study economics. Because you focus on one particular topic and you're not aware of others. So physicists started to use these tools to study biology. I knew that, but then the missing piece was economics and social phenomena. In particular, what um, Jeffrey West did, he dedicated a large part of his life in studying cities. And he found these power laws everywhere in our cities develop and grow and so on. So for example, the GDP of a city and the size of a city form a power law. The number of gas stations in a city, it's a power law. The number of patents in a city is a power law. How fast somebody walks in a city is a power law. It's incredible. There are all these parameters. And so while he was doing this lecture, he was talking about this, and also in a very poetic way, explaining how cities are living organisms. Like he was making an example of the communication systems of a city being like the nervous system, the roads and streets, etc., being like the vascular system in an organism. And immediately, while he was describing this very poetic, but backed by his graphs and science, I, I saw Bitcoin. I saw, Bitcoin needs to be like that. Bitcoin is like a living organism. It works like a city, a digital city. I had this vision, and I went to the data. I started to download all the data, and I found power laws everywhere. One of the first power laws, in fact, is this second graph that you see here. So here I'm listing all the power laws that are really fundamental to understand how Bitcoin behaves. So the second one describes, and I can try to enlarge it a little bit so you can see better. Let me zoom in the graph. So you see the second graph, it's about the price. We have price on the y-axis, and then we have the number of addresses. These are non-zero balances addresses. And you can see, so the way we know it's a power law, this is something that we teach all our students when we introduce this topic, is that if you take this particular type of graph, if you do this particular type of graph, it is not very common in economics, for example. Not many economists use this graph. Uh, you take the log of a price, in this case, log of x of y, and log of x. Okay, and one can go through the math. It's simple algebra actually, and convince yourself that if you have an uh, relationship of a type y equal x to the n, right? N is the power. Then if you take the log of y and the log of x, you're going to get something that looks like a straight line. And somebody can argue, well, this is not a perfect straight line. Of course it's not, right? Because real data is never perfect. But you can see the straight line that I draw here, and they didn't draw it by hand. They use regression analysis. The straight line, it's a good representation of this process, right? Yes, we are above the straight line sometimes, other times we are below, but it's a very, very good representation. In fact, there are, you probably know because you're a professor yourself, right? We can use R square. It's not a perfect tool to tell us how good the fitting is, but it is a tool. And the R squares in these graphs are all above zero point 0.9. It is unheard of for financial data, right? This is almost like what you will get in physics. I worked also in my career in the biological field, in biomed, and we usually don't get this kind of strong correlation, right? And still people publish papers with much less strong correlations. And so you can see the general tendency, it's following this straight line, right? And then you measure the slope of this line, because the slope will give you, again, it's relatively easy to show, from algebra, that the slope of the line, it's the power, and in this case is 1.77, so 178, so basically close to 2. This is really fascinating, because if you are thinking about the addresses as some kind of a proxy for users, right? In Bitcoin, we don't have a direct measure of how many users there are, but you can think that addresses are somehow related to the number of users. So it's a good proxy of users. Then this relates the value, so the price of a network, right? If you are under this assumption that we're dealing with a network, and the number of users of a network. And there is this prediction from this engineer called Metcalfe. He's actually the father of the Ethernet cable, that through mathematical analysis is said, well, the value of a network is not in the nodes, right? A network is a system where you have independent units that are called nodes, where they do certain operations, and then these units are connected to each other, right? And they exchange information. The decision making is done together by interacting, or the nodes interacting. And his point was, um, a network, the beauty of a network is not that it has certain number of nodes, let's say 100 nodes, but in the fact that there are connections. And so the sum, the whole is more than the sum of the parts. And in the case of 100 nodes, the value is not 100, but the square of that, right? So it is 10,000 times. So it's much more valuable when you actually look at the links, and you can show that in a network where all the nodes are connected to each other, that number of links is the square of the nodes. And you can see here we are coming to a number that is very close to that, right? Again, in a real network you will not expect the theoretical value, but it's very interesting that we are very close to that value. So it's basically a demonstration. The Bitcoin is a demonstration that we're dealing with a network. First of all, that is the thesis behind the theory, that Bitcoin shows all these network properties, and network properties are often power laws. Like, for example, this one that says that the value, it could be the utility in general, right, of a network, like how useful the network is to do whatever you want to do with it. Or in this case, given that we have a monetary value, that monetary value actually tends to the theoretical value, right, of the network. And so Bitcoin is a demonstration of that. That is incredible, right? Um, and so this is a very interesting graph. One of the first power laws that I found. I found this other one that is what probably everybody's familiar with, or a lot of people are familiar with, that is the relationship between the price and time itself, right? And we measure time in terms of days from the birth of Bitcoin. That is very fundamental because basically we are describing a process, right? How Bitcoin grows. And the price follows also power law because, again, you see, if I take the log of price versus the log of time, this is something that many people find strange or non familiar, but it's a number, so you can take the log. You can see how these numbers became closer and closer together, right? Almost time is compressed. Then the power law nature of Bitcoin shows up because you get a straight line. So basically, there are more sophisticated tests that you can do to show it is a power law. But the first thing usually is, okay, does it look like a straight line in a log graph? Yes, right? Again, yes, we go up and down, we have the bubbles, right, that are deviation from the power law. But in general, the trend is there, right? It's really striking when you see this graph. And the power in this case is close to 6, 5 something, right? Close to 6. Now, where that comes from? Well, it comes from the interaction of these two power laws. Like, uh, how come we see this relationship between price and time? Well, it's a combination of two power law. One, how price reacts to the growth of addresses, and this growth in this relationship is close to 2 if you round up this number, and how the addresses grow in time themselves. There is this misconception that the adoption follows an S curve, and the S curve is an exponential process, and it has characteristic times, right? There is a point, for example, where almost everybody in an S curve adopts the technology. This is when you get the vertical growth in the S, right? It looks literally like an S, the growth of a process that follows this S curve. Here you don't see that. It's a straight line. There is no characteristic time. It's basically Bitcoin is doing the same thing. And the growth is basically, okay, the number of addresses grow with the power of 3. So this is why if you combine, basically it's a power law of a power law. This one is a power law of a power law. It says the price is proportional to the square of the users if you use addresses as a proxy, and then the addresses grow with the cube of time. So you have a cube to the power of 2, you get 6. This is how you explain this. It's the interaction really of two network properties, because turns out also that many networks grow with the cube. Like, for example, the internet. The internet is not an S curve, it's a power law. Many people misquote that. And S curve are relevant because a lot of technologies do follow the S curve, but the internet doesn't, for example. And the power for the internet is very close to this. It's 2.7, something close to 3. And there are, for example, the spread of viruses is also, it is often studied as a network using network math. It also follow the power of 3. So it's almost like a mind virus that is expanding and, you know, involving more and more people, but it's a good virus. And so when you combine these two together, you get this power law in time. That is amazing. I'm going to stop for a moment to see if you have any questions or any comments on
I
this.
I I have 100, Giovanni, and we'll get to some of them today and hopefully over coming interviews because this is the highly mathematical nature of power laws are also coupled with a very commonsensical way to approach it, and you have both in your arsenal. So we're going to take advantage of that. I want to bring up three power laws that you've mentioned in the world, and maybe you can describe one, two, or all three of them in the context of Bitcoin. And one of them is living organisms, their metabolism, calories, and their size. One of them is the growth of cities. Let's just do the growth of city populations. And the other is one that you just mentioned, which is the spread of viruses.
Yep.
So you mentioned Bitcoin as a type of mind virus. We love that. Maybe unpack that, but also talk about these other two and try to explain to people that maybe aren't as mathematical. How is Bitcoin like a living organism, a city population growth, or the spread of a virus? And why is it that Bitcoin is a mind virus and is exhibiting some of these characteristics that other living organisms are that they exhibit?
Yeah, it's a very good question. So these slides will help us to unpack some of these. So here I mentioned many different power laws. It's just a small sample, right? We already mentioned the planet. So, and it's interesting because we go from the physical world where these power laws are incredibly precise, right? If I show these not as little circles but dot, they will follow exactly the straight line. It's almost scary when you do it, right? And in this case, I'm showing the distance of a planet. Here we measure the distance in what is called astronomical units. That is basically the Earth distance from the Sun. So that will be one, right? It's like we use it as a standard of distance. And then, of course, Mercury and Venus will be a fraction of that. The other planets will be multiples of that, right? Like if you go all the way to Saturn's, we have about 10 distances from the Sun and the Earth. That is how far Saturn is. And here will be the time it takes for the planets to go around the Sun, right? We measure that in here again. The Earth is 1, right? Because it's one astronomical units of the distance between the Sun and the Earth, and it takes 1 year, right? And then all the other planets follow this proportionality law, and we call it a scaling law. So here maybe I can introduce the concept of scale, because basically says as you change the distance of the planet from the Sun, and you change it by factor of 10. So scale means large, big factors, because we want to see the solar system goes, it changes, right, by the distances of planet changes from a fraction of an astronomical unit all the way to 100, right? So this is a situation where you see many orders of magnitude. So the changes are not small, are factors of 10. So this is what we mean for scale when we change this vision of some as a system. Like it's almost like we are taking a drone and we fly over the forest and we see the big picture. We are trying to understand the big picture, and this when scale becomes an important factor, right? So I don't care about the small changes that can be noisy or whatever. I want to see if there is a general trend in how the system behaves when I see huge big changes, and the clue that you're dealing with power laws or you're focusing on scales, you see here how the changes in 10 are emphasized, right? 1, 10, 100, 1, 10, 100,000, and so on. So this is a clue that it's a scaling graph, right? And you can see there is the straight line says there is proportionality, because straight line means a simple proportion, right, between these two things. It's no, the proportion is not between the distance itself and the time itself, is between the scales, between these factors of 10. And when you focus in on the scale, then you see this proportionality. That is the critical thing that I want to communicate. This is why the book that I mentioned, that I suggest everybody to read, it should be in your collection to understand Bitcoin. It's called Scale by Jeffrey West. It tried to explain the relevance of this topic. And you can see these scaling laws, not just in planets or physical phenomena. Like here in these slides, I mentioned physical phenomena, like pure physics, where we see power laws. Like I mentioned, it's not all of them, but a bunch of different physical laws. And these are the what is called a scale exponent, or the power of a power law, right? They change. This number can be negative, it can be positive, can be small, large, and so on. But then also in other phenomena, like you mentioned, metabolism, right? So this is a famous power law that is called the Kleber's law. And the other thing that I should explain, because it creates a lot of confusion in the community, is the use of laws, right? Laws, I think a lot of people don't understand how we use this term in physics. Even the laws of gravity is not ever understood in physics as something that is 100% sure. There is no such a thing in physics. It's a pattern. Maybe gravity is a pattern that we have never seen violated so far, and so it's a very strong pattern. But any particular pattern that is there for a reason, so there is some causation, there is some mechanism, it's a law, because it says that there is some kind of mechanism, there is some kind of reasons, right? That this is why I dislike when other people in the community, maybe they want to reproduce the results of a power law. That is great, because we need more people exploring this topic. But then they change the message, right? So I notice, I don't try to be polemic, but I notice somebody is using the word power curve, right? Because maybe we want to avoid that law, thinking, oh, maybe it's too much calling it a law. Well, there is a point with this. There is a reason why we do it, because it is a law. It's a proportionality law. It's a scaling law. So anyway, it's basically a pattern that is very strongly observed and that is consistent, and probably there is a reason why. And so in this case, with metabolism, you see, it's much less rigorous, right? You see the dots here, right, that represent each single species of animal, right? We have mouse, guinea pig. Maybe I can make it a little bit bigger. Uh, so we have all these animals, right? And notice all these animals have different lifestyles. They have different size. Some of them are predators. Some of them are prey. There are birds that are flying. We have different lifestyles, different environments in which we live. But in general, they follow this proportionality rule, this scaling law. And the scaling is between the metabolism and the size. So, and notice again, right? See how we go from 1, 10, 100, 1,000. This is again a clue that we're dealing with a log graph. We are looking at the scale of the phenomena. Um, and we have a straight line, so it means that there is a power law. In fact, in this case, it's metabolism, so the energy equal to the size to the 3/4. This is how it goes. And what is the relevance of that? So there are two things, right? The first one I was saying,
So it's less than one, the
it's
slope?
less than one. So the first thing to notice is, differently from the planets, the dots do not follow exactly on the straight line, or at least not so precise. And the reason is because, yeah, biology still has this proportionality, but it's not perfect, right? There is some variability between animals. We have different lifestyles. Notice, even between species, here we have a man versus a woman. We have different body compositions, right? Men tend to be more muscular, so they use more energy than the average for its size. And notice, for example, these big deviations of the small birds. The small birds kind of pay the price in flying by using more energy relatively to their size, right? According to this proportionality rule. And so there is a trade-off right there, right? They decided, okay, it's okay to consume a little bit more energy because, that requires more food, etc. But we get this evolutionary advantage of flight, right? So there are a lot of things you can learn just by spending time and looking at this graph. This is why finding it in Bitcoin is so powerful, because it tells us, it gives us a framework, right, that allows you to come up to certain conclusions, some understanding why we are below the power law, why we are above, what is happening, to Bitcoin in terms of its growth and evolution, where it is. So it helps you to reason about the phenomena. This is why I make a big deal about this not being just a model. It's much more than a model. And so you see, there are all these things that you can learn from this graph. One important thing to learn is, given that the power is less than one, this graph is all about economy of scale. It tells us that if we go from, let's say we double, right? We double the size of an animal. Uh, Roughly, right? We have two. Then we take the power of three quarter. So we want to see how much more energy we're going to get if we double the mass. If you didn't know about this power law, you will say, okay, maybe there is some proportionality, but it's a direct proportionality, right? I double the size of an animal, I get two times the energy. Well, it's not like that, because a 2 to the 3 quarter give us 1.7. So you actually get a discount in how much energy you use, 30%. And it doesn't seem a big quantity, but it is for an animal needing to eat 30% more food will be very time consuming, and it will not be as good as having that discount by the time, actually, because it's a non-linear process. So the effect becomes bigger and bigger as you start to change the size of the animals by a big quantity, right? So if we go from the mouse to the elephant, right, roughly we go, let's simplify, 0.1 to 10,000, right? So 100,000 times. An elephant roughly is 100,000 times larger or heavier than a mouse, right? But notice the energy, right? We go from 0.1 to 1,000 on the y-axis. So that means only 10,000. So the size is 100,000, but the energy consumed is only 10,000. So it means there is an advantage, there is a discount of 10. So if this relationship was not there, the elephant will need to eat 10 times more food. In fact, probably will not exist. The elephant will not exist because he's already eating a lot of food, and 10,000 more will be unpractical. And this is why it's so interesting to study this phenomena, looking at the scale, what scale implies, right? So somehow, and then a physicist or a scientist would not stop there and say, where that three quarter come from? So it's almost like a fingerprint for the phenomena. And now your next step is, okay, let me go deeper in the rabbit hole and figure out where this three quarter comes from. If you read the book Scale, he dedicates an entire chapter to this law and tries to explain. It has to do with the vascular system of the animal, the fact that nature finds a way of optimizing energy distribution when you have a large animal, metabolism rate, slowing down metabolism as the animal becomes bigger. So there is an entire science behind this power law, and you can go deep in understanding what is going on in the animal and learn a bunch of things. This is why they are so important. Why is a big deal, and so this is in biology, in physics, in planets and things like that. But it also show up in languages, like
Can
that.
I ask you before you
Sure.
get to languages? And we'll definitely put this Jeffrey West book scale on the screen for people
Yeah.
and provide a link. Can you tell me, is the relationship also a power law for animals that live in the sea? Because I noticed that these are land animals. So is it different
Correct.
because water gives you a different gravity and mass?
Exactly. So you will have something similar. It will be still a power law, but it will be a parallel power law. So probably, basically less energy for a given size, because the water gives you support. The scaling is still there, right? The scale is going to be there. In fact, actually, you see, I don't have this graph with me. If you go to animals that are not mammals, for example, right? Because these are all mammals with maybe, okay, birds. Uh, they are they are more similar than different. Um, in comparison with, for example, reptiles. So if you go to reptiles, because we have cold blood, etc., you will still get a power law, but then it will be a parallel power law. So there is a shift, there is a shift, but the proportionality is still there. In fact, actually, I saw a graph, and maybe should add it to my slide, where you go even to unicellular organism. It's really crazy that proportionality. It goes all the way to even cells. Again, shifted a little bit because it's not exactly the one for mammals, but the proportionality within the same category is still there. And so it's why, you know, Jeffrey West wrote an entire book about this. It starts to open your mind about all kind of different phenomena. Right now, we just mentioned physical world, animals, metabolism, biology. But then, I get this pushback all the time because people say, "Well, okay, it works for planets, it works for animals, but what about human beings? Human beings are not." You cannot describe human beings using math. Well, it's not true because human beings are part of nature. First of all, when we do interact, this doesn't deny free will because we still have some level of free will as individual, but when we work together, our interactions, the efficiency of these interactions, how they work, etc., they still follow mathematical laws, and we have so much evidence for that, right? Somebody even challenged me one time. They told me, okay, fine, even cities or other human creations do follow power laws, but what about history? History for sure. And then it took me 5 minutes, and I found several articles talking about the number of casualties in a war follow, and that is an historical event, follow power law. In fact, the time in between wars follow power law. A lot of many other things that we do as humans, they follow these power laws. They are very universal. So we use this term in physics. We call them universal. This is one of the things that physicists love, when we can make a comparison between very different things and say, look, yes, these are different. They have individual, but particular behaviors, but the general behavior, it's universal. It applies to so many different things that initially you will think are not related at all. So languages, for example, right? So this graph shows how many times a word is mentioned in a given language. It can be, V, N, dog, whatever. And then the rank, right? Is this the most uh, mentioned word, the second mentioned word, and so on, right? So if you organize them like that, you get this famous power laws called the Zipf's law that shows how common languages are. You can actually define, right? And maybe there is a reason why a language is a little bit above and the other one is below, but in general, you can see they kind of on top of each other, saying, no matter how different languages are, they are very similar in terms of this mathematical structure. It is really fascinating, right? And again, if one spends time, one could understand many different things about languages by only study these power law. And it even includes like dead languages, right? Like Latin or Sanskrit or something. It's really fascinating. And then, cities. So here in this graph, we have something similar where I'm organizing the rank of a city, right? If it is the largest one, second largest one, and then how many of these cities there are, how many cities with a given populations there are. And they follow power law. You see many power laws because they show different regions inside that. This could be different states, for example, inside a particular nation, and so on. It's really cool to see this universal behavior. And here is a graph of also a city again. Let me zoom out a little bit. Where, in fact, this is from an article that was discussing this, like, I don't remember where it took it, but I think it was the New York Times or something, where they discussing the science behind these, and they use this title, predictable cities, because actually it's a predictive tool. That is the other thing that many people push back, say, well, okay, Bitcoin has done this so far. How do you know that it will do in the future? Because mechanism, if a mechanism that produce the power law up to now exist, then this mechanism will not disappear, will continue to exist. The way that Bitcoin is going to grow is based on how it behaves, its nature. And so you will think that they will continue, right? Now, it's possible, like, we were discussing before, um, these shifts, right? Uh, if an animal decided to go and live in the water, it's not that it's not going to follow the power law anymore, but it will be on another realm in a sense, right? So the power law now will shift and change a little bit. So it's possible that there is some big event in Bitcoin that will create a phase shift. The proportionality probably still there, but it could create some kind of a jump or whatever. That is possible, but it will have to be like something as drastic as an animal deciding to go and live in water, right? Uh, I don't see anything like that when people mention, and we can spend a little bit about discussing that, but when people mention ETFs or nation states, etc., no, this is simply part of this proportionality, right? It's just another order of magnitude. We go from individual investor to small banks to institutions. It's all part of this progression of sizes, of scales. And so the power law actually can even predict, right, that at a certain point institution will come in because the size of a system is much larger. So you have these large investors coming in. But you see here all these parameters: crime, GDP, income, patents. Of course, we are different metrics, but you can normalize them to plot them all in the same graph, and they all look the same. They all look like power laws. Again, notice you see here is the log. That is a power law because we are taking the log of a x-axis and we are taking the log of a y-axis, and we get a straight line, right? That is,
And the slope on the cities
I,
phenomenon
I think
is.
it's 1.2 or something like that. I don't remember. But yeah, it's a particular number and it's above one. Uh,
So you've answered basically the question here by process of elimination. So now that we know that the power is around 6 when you think about time and Bitcoin's price, I find it fascinating that you're deconstructing this into two components, one being time versus the addresses, and the other that's closer to a slope of 2,
right.
and the one that's closer to a slope of 3 to get the product of 6 is time versus price. Can you remind me which one is the
Yeah, and
has
and
the
and,
power law
and
of
just a
3?
second. This is a slide. There are others. In this case, is we have on the y-axis. So this is for different cities, different times. So on the x-axis, we have a population, and here is how large of a space the city is occupying. In this case, the power law, you see here how it's expressed is like a straight line. So this will be the y-intercept, and then uh, the number here uh, multiplied by x is the slope, right? Is the slope of a curve. This is a typical mathematical equation for a straight line, right? The a constant plus um, the slope times x, right? Notice all these numbers are below one, meaning so here, and also look at this. These r squares are pretty good, 0.81, 0.7, right? In Bitcoin, we have 0.95. It is crazy. Like I told you, it's crazy. Like people publish entire papers on these relatively good but not amazing R squares, and we have in Bitcoin a much higher power law, much higher square. The fact that it is less than one, it means that as the city grows, there is some kind of optimization, right? Because one means economy of scale in how the space is used, probably because the city starts to build skyscrapers, right? So it utilizes the space in a much more efficient way. But it's really fascinating, right? This is similar to Kleber's law. really beautiful thing, right? And you can see it's very these are um, cities in China, but it will apply also in the United States, in many different countries. Very, very, very beautiful signs showing that human activity is also amenable to this type of analysis. So there is that when people push back about Bitcoin being a human product, it's no point at all, because we have an example in cities where it's human made, and it does follow power law. And this is the book that was mentioned. Notice the subtitle: Universal, right? Laws, are laws. These are laws of growth, innovation, sustainability, and the pace of life, organisms, cities, economies, and company, everything. So it's a very beautiful topic, to study. Um, Tell me one more time, because of what I was talking about, all these kind of
Yes,
forgot your
the
question. Tell me again the
the
question.
question, what I really want people to take away today is, because we've talked a lot about the power law, we can talk so much about the math, but what you're helping us doing is understanding power law nature, why Bitcoin is a power law, and I want people to understand that if the slope is 6 when comparing time and Bitcoin price, you're saying that it deconstructs into 2 times 3. The 2 is the slope of the line comparing, or I should say, relating time and addresses, which is the size of the network. And the 3, the slope of 3 is relating time and what?
And the growth of addresses themselves, right? So it turns out that addresses grow with the cube of time. And that is, I almost fell from the chair when I started to look it up, and I found out that many different things follow with that cube. That actually, I need to go in the rabbit hole even more and figure out why the cube. Where I can I can demonstrate why square. It's easy demonstration. In fact, I can tell you very quickly the proof. I can make a more formal proof, but the proof is this. Imagine you have a network with n nodes, and everybody's connected to everybody else. So every node is going to have about n connections, right? Because you connect to everybody, n minus one. So if n is big, it's going to be close to n, right? So you have n nodes, and possible connection for each node, n squared. This is why we get n squared, roughly, right? We just did it in our head. Now, you can even do more formal proofs, and you can show that this is what happens.
Can you go back, Giovanni? I want to make sure that we're summarizing it for people, because I was not speaking correctly. So can you go back to the one with the
This one?
one right above?
This one?
Yes. Okay.
Yeah,
So this is what I want people to understand here. The top 3 graphs here start on the left. We have addresses power law in terms of time.
yeah,
That is a slope of 3, and then price as a power of addresses too. So what we're starting with Bitcoin, because there's physical evidence that Bitcoin price follows a power law. That's the whole theme here. But what it really is physical evidence of that happening in 2 steps. The first step is time, and you're relating the growth of addresses in relation to time. And that is the Bitcoin network.
yep,
Then Bitcoin achieves price in the market once it has users, and the price as a function of address growth over that growth, because the time is in the addresses. So
correct.
that's where you get price as a power law of time coming out to 6, that following the slope of 6 there.
Perfect.
So that is it's a revelation of sorts to me today, and I want to make sure that our viewers are coming along with this discovery
Yeah,
here for me
exactly.
today.
So this is why I use this as the core, kind of almost like a visual summary of a theory, right? And again, it's a theory because it gives us a framework, right? A theory in science is exactly that. It gives us a framework like evolution, right? Now you can understand many different things around you in terms of biology by using the theory of evolution, right? Or the Big Bang theory, right? Says, okay, I can understand things in the universe by understanding what the theory says, right? That the universe started from a point. The universe was much denser at the time. All these things that are associated, and there are many evidence to support the theory. And this is what this is trying to do, is say, okay, this is all the evidence to support the theory. And what the theory tells us is that Bitcoin is a network and is following a very precise pattern, and is not like a normal asset. It's a non-normal asset follows a power law. Is Bitcoin is unique in that, and it's unique because it's not an asset. It's something much more. It's this you can, in fact, start to from here and then write an entire philosophy book, right? Why Bitcoin is a network? Why what that implies? It's my understanding is this experiment that human beings are doing in creating value. They want to create uh, some kind of objective system that represents value in all mankind. And we are doing it by working together, interacting together, and the expression of what we are creating is that the whole is bigger than the sum of the parts. That is what a network is all about. This is why nature prefers networks over other things. Imagine all the cells in our body were just like moving around randomly. We will not have life, right? Life is actually a network expression, right? Is the fact that these cells that instead of working individually, like in a pool, of a microorganism, they decided to work together and create something that is much more than the sum of the parts. And this is beautiful. It's a beautiful message about what Bitcoin is, that destroys any uh, criticism that is a speculative asset, that is a pyramid scheme. This destroys that, because it say, look, there is intelligence, there is beauty, it's a living organism, it's something much more than an asset, right? So I don't understand why people don't embrace this. This should be like, I was not even invited to speak at a conference. This should have been a plenary speech, if this, because even if 1/10 of this is true, it changes completely our vision of what Bitcoin is. Uh, why we have all these power laws. It's basically another thing that happen often when you have feedback loops. That is also a source for power laws. It's another expression. There's another mechanism to create power laws, and this is a bit of a big feedback loop that represents how Bitcoin works. In fact, I even think about like the history of Bitcoin, right? You can start anywhere, but imagine we start with the big bang of Bitcoin. That is when Bitcoin was created, right? Uh, January 3, 2009. So Satoshi created Bitcoin. It was a small community, a small group of friends. His cypherpunk friends in his little community, and these ideas were circulating for a long time, but when he actually had a concrete, very precise way of achieving these goals of creating this store of value or alternative monetary system, people started to react to that, right? And this is how it's expressed here: demand of a store of value rises, right? So people realize, oh wow, this now could work. There were criticisms, there were pushbacks, but a lot of support too, right? If you ever read this, uh, newsletter, not newsletter, but uh, this site where Satoshi was talking with these cypherpunk friends, and some of them gave him support in terms of looking at the code, debugging the code, running the code, like Alfining. I'm running Bitcoin. Uh, he put energy, he put time, he put value, right? The value maybe was no monetary at the time. The power law, by the way, says day one the price was 10 to the minus $17, basically nothing, but people were putting their time, their energy, their intellectual prowess, to help Bitcoin grow in value. And that is expressed by this power law, the fact that it's spreading like a virus. Now, why is spreading like that? That is typical of network. In fact, um, I found a lot of other networks like the internet, but also recently I found that this archive of movies, uh, um, reviews that you find online. That one also grows with the power of three. So a lot of examples of why is three? I don't know. It's something that we need to explore. That is the beauty of science, right? We are always exploring, but it's very universal. This value, growth of viruses, growth of the internet, follow power law 3. It's also tell us there is no atypical time. There is no like people say, oh, there will be a time where it explodes, and say, no, Bitcoin is doing, the beauty of this message here is Bitcoin is doing what has done since the beginning. There is, it's not going to be a critical time. We don't need adoption of the entire world, because every time. So if a network goes up by a factor of 2, the price goes by a factor of 4. So we need to go by a factor of 100. We need only 10 times. And right now, let's say we have maybe 100 million users. We need a billion of users to get $10 million Bitcoin. We don't need the entire population of Earth. So there are a lot of things that you can learn by using this framework. Then you see in the loop, as the Bitcoin price rises, so you see this is how the network responds to the growth of the addresses with the square of the growth. This where I put this diagram. Then you see, when you see, like you say, the interaction of these are one network property, growth as a power of 3. This is how network grow as power laws. I have also other papers. I'm writing an entire book on this topic where people will find all the evidence and all the arguments. But there are papers that show, they studied actually social networks, and they show both the nodes and the links grow as power laws. There is a lot of evidence for this. So if you're dealing with a network, two network property together give us the growth in time. And then what happens? The miners, because Stephen actually calls Bitcoin a meta network, because it's a network of networks. There is the social network aspect, right? We are going to conferences, we are having videos like these. Bitcoin is much more than just an asset. There is interaction at all levels, social network. But then there is the mining network, right? There are all these machines that interact with the social network. So it's a meta network. It's a network of networks. And the miners come in because they are attracted by this value proposition, by this store of value growing, and they contribute, right? Because without miners, we will not have Bitcoin at all. And they found out that actually the hash rate, right, that is an expression of how much activity there is in this network, the hash rate, it's related to price through a power law. In fact, it says that price equal the hash rate square. So there is a power law. And I added this difficulty adjustment because it creates a parallel network, a parallel feedback loop. It keeps it's basically like an inhibitory process. We found a lot of this inhibitory process in nature, like in the brain, for example, in the muscle. You need a break, right? Bitcoin need as an accelerator, but also I need a break to function. You will not have a functional system unless you have some kind of way of controlling the system. And this is the difficulty adjustment. Really genius by Satoshi to introduce this particular system. And that creates more feedback loops that actually reinforce all these power laws. And then, if you continue, here we get more capital, more investment, because we are creating an infrastructure around, like a city, right? A city is, infrastructure of city is fundamental to create a city. Basically, the mining structure, the infrastructure is represented by this material thing that is also creates some kind of link to the physical world. When people say, "Oh, Bitcoin is not supported by anything," no, it's supported by all the energy that is needed to run the system. It's a link to the physical world, and then the network continue to grow because people feel more secure. The value is not just in the price, but also the fact that there are all these operations that creates a very secure network. And, people don't necessarily buy Bitcoin because they say, oh, it's a more secure network. But it's one of the things that, at least unconsciously, is there, right? You will not want to invest in Bitcoin if it was easy to hack and so on. If you could do a 51% attack, and more user there are, more investment there is in mining, more secure the system is. It's for sure something the institutions care about, right? They consider. This is why, for example, institution didn't come in until the system was big enough to ensure that level of security. And then this creates more demand, and then the cycle continues, right? Almost like a snake that bites his own tail. And you will have been it will have been surprising if we didn't see power laws given all these feedback loops. But every stage of Bitcoin growth and evolution is supported by a different power law. That is amazing. I think I say that is the only scientific coherent theory of how Bitcoin works and how it evolves. Nobody else has this theory. And so, I would like more people to be familiar, studying it, and also push back, because it's part of being doing science to have also criticism. The problem is that I never heard one single person making a serious attempt to criticize this view of Bitcoin. Is usually all the comments I get, negative comments, is because people are not aware of the theory, they don't understand the math. I never saw a serious professional pushback of this theory, because it will be very important, both validating it but also criticizing, to make it stronger, or see if there are weak points in the theory. So I would like to do, to see more people do that. By the way, offline, I was mentioning that I'm creating this institute. It's called Bitcoin Scientific Research Institute, where we would like more people like you, people in academia, to come and study Bitcoin, taking it seriously from a scientific point of view.
And we definitely want to continue to explore the scientific, physical nature of Bitcoin, its power laws. I personally am going to obsess over these individual power laws that make up the price power law in time slope of 6. These 3 and 2, I'm going to go read the Jeffrey West book, and we'll bring you back on, Giovanni, to discuss all of my follow-up questions. We'll actually get to look at your slide deck, all the slides that we didn't get to today, as well, and maybe pick up some questions for next time. Giovanni Santostasi, PhD in astrophysics, educating us on Bitcoin power law, the fact that it is a law because it's mathematical in nature, but it's a theory that Bitcoin it's a theory that Bitcoin power laws are, or that they exist, and that we must confirm or disprove this theory whether Bitcoin is a power law, but the power law itself is a law because it's mathematical in nature. I hope I had that all correct.
Yeah, and,
Please
and
tell,
not just
yep,
mathematical
and
in
please tell
nature,
people
but
where
also,
they can find all of your work as well as you answer the question,
yeah.
please.
So I want to add one thing again: the mechanism, right? Because in physics, the mechanism is fundamental. When Kepler found that law that I show you between the distance of a planet and the time, we didn't know what the mechanism was. There was a power law. We found it. It has a precise mathematical pattern. But then Newton, 100 years later, came and said, the mechanism is gravity. The reason why we observe this pattern is because there is a fundamental force between the planets, and can explain why they move, or why they behave in a certain way. So it's the mechanism, right? It allows us to go deeper in trying to understand what is going on. Same thing with this power law. It's the fact that we have so many power law points to the fact that Bitcoin is following a precise mechanism of growth. It's not random. It's not, you know, uh, speculation. It's something much deeper. There is some mechanism of interaction between the users of the mining, etc., that creates this kind of intelligent system. Like this is why the analogy with living organism is important, because living organisms have wisdom, right? There is wisdom in how the body works, and this economy of scale, right? When animals grow and become bigger. So all these things allow us to see Bitcoin from a completely different framework. And it's almost a tool to answer almost any kind of question that you have about Bitcoin. So it's a powerful thing.
We really are fascinated by this occurrence of Bitcoin's power law and its relationship to nature, living organisms. So, Giovanni Santostasi, thank you so much for joining us
My
today at the
pleasure.
Bitcoin Layer. Please tell people where they can find you online, your work, your show with Stephen, and everything else that you're working
Yeah,
on.
and I can send you some links so if you want to put them in the comments. But I'm very active on X. I have about 50,000 people follow me on X. Um, you can find me. The easiest thing is BTC space power, and then I will show up, and you can follow me there. I have a YouTube channel. We do shows uh, every week about the physics of Bitcoin. Like for example, tonight at 8 p.m. Pacific time. Um, and I have a website called bitposeidon.com. You can visit that one. There is a newsletter that you can sign up for free. Um, and I'm writing a book soon. I'm going to publish a book called The Physics of Bitcoin, where I'm going to put all this information, right? I have almost 350 slides in this presentation. So good reading when I send it to you, because there is so much to explore. There are so many things. And Bitcoin deserves to be studied scientifically. That is my point of view. Uh,
We couldn't agree more. You've given us months and months of study material. We cannot wait for your book. Do you have an ETA on the
I will try
publication?
to do it by the end of the year if I can. Yeah, I will have
That's
it
that's
for
that's
Christmas.
it's what I always tell myself. So we
Exactly.
wish you the best on your journey in finishing the book. We can't wait to read it. Giovanni Santostasi, thank you so much. I'm Nick Bhatia. We'll catch you guys next time.